Here we're working on some problems that have to do with trigonometric functions. In this first one, it looks pretty complicated, but it's not too bad once you plan it all out and understand what it's really asking. It says, suppose the depth of the tide in a certain harbor can be modeled by y equals 24 plus 5 times the cosine of pi over 6 times t, where y is the water depth in feet and t is the time in hours. Consider a day in which t equals 0 represents 12 midnight. So let's just think about that. T is hours, and then we'll have the actual time. When we start at midnight, so that's 12 midnight, t is 0. So at 1 o'clock in the morning, t is 1. I'm going to go up to 6 here. This is 6 a.m. So when t is 6, it's 6 a.m. I'm going to leave a little space there, and we'll go to, let's say, 12 noon. T would be 12 at 12 noon. And that's enough for now. We're going to test some of these values here. Now, our function is y equals 24 plus 5 times the cosine of pi over 6 times t. And when I see this pi over 6 times t, what I think to myself is, if I test some values with multiples of 6, I can get some easy values to test, because I can figure out what is the cosine of pi, or 2 pi, or 0 is pretty easy too. So actually, let's try that first. Let's check out 0. So at midnight, when we start here, if I put in 0 for t, I get the cosine of 0. And remember, in our unit circle, cosine is the x, and here's 0 right here, so that's when cosine is 1. So at midnight, the cosine of pi over 6t is 1, so we get y equals 24 plus 5 times 1, or 29. Now let's fast forward a little bit to 6. Remember, we want powers of 6 here to make the math easy. So if I put in a 6 for t, it's going to cancel with this 6 under here, and I just get pi. Pi is over here, and this is where cosine is negative 1. So in this case, y equals 24 plus 5 times negative 1. So that is 19. And then if we continue on, we go to 12 noon, what we'll find out is we're back up to, well, that would make this 2 pi, so we're back to 1. And what you can see here with the cosine, it's at its biggest value right here. It gets smaller and smaller and smaller. 0 there, it gets even smaller, it's negative 1. That's its biggest minus value. And then it starts getting bigger again, up to 0, back up to 1. So we've found the high point and the low point. So it starts out at 12 noon, or 12 midnight at the high point, and it continues on till 6 a.m. where it's at its lowest. Then it goes back to 12 noon where it's at its high point again, continues on to 6 p.m. where it's at low tide again. So we would have high tide of 29 feet at 12 midnight and noon, and low tide of 19 feet at 6 a.m. and 6 p.m. And that's how to solve that problem. Let's look at some different ones. So this one says solve tangent squared of x minus secant of x equals negative 1. And they're telling us that x is between 0 and 2 pi, but I guess not including 2 pi. So how are we going to go about this one? One suggestion is when you see functions like tangent and secant or cosecant, is to try to put everything in terms of sines and cosines. Sometimes that can be easier, and it'll allow you to see some identities that you might be able to substitute in. So let's try that. Tangent squared is the same as sine squared over cosine squared. And secant is 1 over the cosine. And then we have negative 1. Now that didn't seem to get us anywhere very useful, except I notice I've got a cosine squared for a denominator here and a cosine for a denominator here. What I'd like to do is make the denominators the same. So I'm going to multiply this one by cosine x over cosine x. That would give me sine squared x over cosine squared x minus cosine x over cosine squared x. Now I've got cosine squared x for a common denominator. And then over here, I think I want to do the same thing, so I'm actually going to multiply this one by cosine squared x over cosine squared x. So let's do that. So we'd end up with a negative cosine squared x, because I multiplied a negative 1 times that, over cosine squared x. Now, I can multiply both sides by cosine squared x and essentially get rid of the denominator there. And I've got sine squared x minus cosine x equals a negative cosine squared x. What I'm going to do is just a little rearranging. I'm going to move this negative cosine squared x over here and the negative cosine x over here. I'm adding a cosine squared x to each side and adding a cosine x to each side. That comes out as sine squared x plus cosine squared x equals cosine of x. And this should jump out at you. Sine squared plus the cosine squared equals 1. That is a major identity, the Pythagorean identity. So this comes down to 1 equals the cosine of x. And where does the cosine of x equals 1 equal 1? Well, at 0 and 2 pi, except 2 pi is not included. So 0 is our answer. All right, let's try one more. And this one is a tricky type. What we're actually doing is having a trigonometric function in the form of a quadratic function. I'll show you how that works. It says, identify the obtuse solution of the equation, and we have 16 plus 40 sine theta equals 25 cosine squared theta, where theta is between 0 degrees and 360 degrees. So first problem I see here is that I have a sine and a cosine, and if I want to do this as a quadratic, I want one function, not two different functions. So I want either all cosines or all sines. The cosine squared theta is the easiest one for me to replace, because by the Pythagorean identity, cosine squared theta equals 1 minus sine squared theta. So that's what I'm going to do there. I've got 16 plus 40 sine theta equals 25 times 1 minus sine squared theta. Multiply that 25 through, I get 25 minus 25 sine squared theta equals 16 plus 40 sine theta. And now I'm going to do some rearranging and set this equal to 0 because I'm going to treat it like a quadratic. So I'll add 25 sine theta to both sides, 25 sine squared theta. Let's see, 40 sine theta, and I'm going to subtract 25 from both sides. So I think I get negative 9 there. So there is my quadratic. I've got a squared term, the sine, regular sine term, oops, I forgot my theta, and a number term. Now, treating this just like a quadratic, you can put this in the quadratic formula if you want. You could put negative 40 plus or minus the square root of 40 squared. Let's see, minus 4ac is actually going to be plus 900. And let's see, 1600 and 900, oh, that's easy. So, oops, let's get our 2a under here. So this is going to be negative 40 plus or minus the square root of 2500 over 50. And the square root of 2500 is just 50. So this is 50, and we can get a 10 out of each one. So really, we've got negative 4 plus or minus 5 over 5. And you end up with either 1/5 or negative 1 and 1/5. But the sine function really only goes from negative 1 to positive 1. So this doesn't make sense, and we're going to toss it out. But we've got 1/5. That is what sine theta equals. I'm going to write that as 0.2 instead of 1/5. So sine theta equals 0.2. And if you plug that in your calculator, do an inverse sine, what you get is theta equals 11.54 degrees. Now, we have to do a little bit of thinking here. They asked for the obtuse solution of the equation. 11.54 degrees does not sound like the obtuse solution of the equation. And let me draw a little picture. I've just got some space over here. So 11.54 degrees, something like that. So there's this value. That's theta right there. There's a value where the sine is going to be exactly the same, and it's over here. See, the y value is the same on either side. So the obtuse solution is going to be the same angle over here, and to find that angle, all you have to do is subtract 11.54 from 180. So once you find the acute solution, finding the obtuse solution just means subtracting that from 180, and that would be 168.46 degrees. So that's a little bit of work with some trigonometric functions. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethisSchool.org. Thanks.